An A4 sheet of paper has side lengths in the ratio of 1:2. If the paper is folded as shown in the diagram, what is the perimeter of the resulting pentagon? So I start with marking the vertices, and E is a point where we fold the paper the first time. Okay, and next, so the point D you can see has moved here now, so I've named this D, and which also means that EDC, this is a square. Okay, so we go on to the next slide, and so again I have introduced this F and G, and because we fold along F and G, which brings the point C to the point B, so that's why I wrote here C and B. So that would mean that this divides the length, or the width, whatever you call it, maybe the length. So it divides it into two, which would mean CF is equal to FB. Okay, so then I start to write down the side lengths, and DC would be equal to DE, and that is 1, and that would mean that EC is equal to root 2, and AB is 1, and then you see CF is equal to BF when it is, that is how you can fold. I mean, C goes on to B when it is being folded into half, so CF is BF, and BC is root 2, so CF equals BF equals root 2 out of 2. And so I mark the point X here just to note that EXCD is a square and ED equals CD, and AB is 1, okay, because obviously CD is equal to AB, so that means AB is 1. And next, if you have, this is CF is equal to BF, you see another thing that happens here is CF is also equal to GF. Now what happens is, here you see this triangle CDE, because it's right angled and is isosceles, CD is equal to DE. Okay, so you can say that CD is equal to DE. I can't say equal because it will look like BC is equal to ED, which is not the case. So CD is equal to DE, and therefore angle DEC is 45 degrees, and because CD is parallel to FG, DE is parallel to FG, you would have angle DEC equal to angle FGE equal to 45 degrees, which really means, angle C is also 45 degrees, which would mean that both of these triangles CFG and CDE are similar. They are isosceles right angle triangles. Okay, so that is my explanation for saying that CF equals BF equals FC equals FG, and that equals root 2 out of 2. So in other words, what I'm saying is CF is equal to BF, so this is BF, and that is equal to FC, which is CF, same is equal to FG. That's what I'm saying, right? So the next part is to work out what GC is, and using Pythagoras theorem we get GC is 1. FC of course is root 2 out of 2, so GC is 1. So now you see, as part of the pentagon, we have found what GC is. So we have what GF is, because GF, we know what that is now, and we know what this is. We can now find what EG is. Okay, we know what GF is. That is equal to root 2 out of 2. We know what BF is. We know what AB is. AE also we know. We just need to find EG, and we do find EG is equal to root 2 minus 1. So we do know all the sides now. So AE is root 2 minus 1. The reason is this whole thing is root 2. And this bit is 1. So this bit would be root 2 minus 1. So to write down all the side lengths of the pentagon, we have 1, root 2 out of 2, root 2 out of 2. BF is root 2 out of 2. GF is root 2 out of 2. And then EG is root 2 minus 1, and AE is root 2 minus 1. So now we need to add them up. So the final answer, the perimeter, would be 3 root 2 minus 1. And this is the answer.